I want to welcome everybody. It's nice to see familiar faces again. It's been 10+ years, way too long, but I'm glad to see everybody happy. Or at least we've still got COVID in one piece. I think we got a really good agenda for today. Magna is going to give an overview here to kind of get us started. TriStar is going to show us essentially a hour-long demo related to Creo-RecurDyn, okay, which, as you know, just out of a little curiosity, how many people were on Creo 5 maybe still? Anybody? Creo 6? 7? Anybody on 8? Nobody's on 9 yet, I'm assuming.
Naturally.
I got it on my laptop.
Yeah, exactly.
It's okay, because it's at the first release.
Yeah.
We wait 1 year before we upgrade it. Let everyone else have it.
Let everybody else have a headache. That's reasonable.
Let's wait till it's week 2.
As long as the computer doesn't go off or start smoking. So like I say, TriStar's going to do a demo on Creo-RecurDyn. SICAM is here. They're going to talk about multi-jet fusion for additive manufacturing. And machines, which sounds real interesting. PDSVision is going to talk about using Creo Freeform services for industrial design, not just using boundary plans and so on. Okay. We'll of course have another break, so visit with the vendors, and then Enginsoft USA is going to talk about Creo-RecurDyn MVP interface. I'm not sure if it's obviously I think it's more and more involved. It's not just a buzzword anymore. Drawings are starting here for some companies, and then we'll finish up like we usually do with the product drawing and vendors. So, no further ado. Get up and good morning.
I was out, forgot what time it is. My name is Mike O'Donnell. I'm the Director of Operations here at Magna. What that means is I'm sort of in charge of the people sort of consulting we do. That's about 80% of our business. But stepping back, we're really pleased to have you here. For us too, as manufacturers, COVID is sort of a good place now. And our business is doing very well. I'm going to share with you some trends that we're seeing in the industry and consulting area with manufacturers. And business has been good. Companies are growing. Magna has sort of 3 areas that we work in. One is supporting manufacturers directly through their operations to grow, and people, install new technologies and services into the industry 4.0, to bring talent and engagement, and also to do business-to-business marketing and growth strategies. So those are sort of our core, and the way we've developed those over the years is that's because of manufacturers like you have requested. We started out about 25, 30 years ago really just doing plant layouts, more or less, plant layout work, which, and that's still important, but that's not really the #1 thing in the industry today. The second area that Magna works with is the generation of talent in the community, from the high schools and the community colleges, such that there can be a talent pipeline for manufacturers like yourself. That's a challenge. As you all know, there's a great talent shortage, and it's, although we're doing things with internships and structured programs and helping the community manufacturers drive that, it's just not enough people. It's just not enough people. At most of the manufacturers we talk to, hence, the 2 biggest growth areas we're seeing at all the manufacturers right now is how can I do more and satisfy the demand of what I have. And so we've seen in our business, we've gone up, our revenue's gone up, and we do consulting services. That includes operations, engineering. Andrew's one of our senior design engineers, with clients, right? And the 2 things are, operational excellence. We're right back again to how can we streamline our flows, how can we do tack times, how can we take waste out. But the real change is that now, with the price of devices like cobots, like machine monitoring systems, like sensors, like data integration of manufacturing systems into your ERPs, they're so affordable now
manufacturers have actually started, I mean, we've been waiting a long time for that innovation. It was just too expensive before. But a cobot now, you all know, you can buy a cobot installed in place that can tend probably two CNC machining centers, or 10 and pack out potato chips bags in a box and scrap it. You can do 2 of those for $100,000 installed, and before you need 2 operators. Do those numbers up, and if you need 15 operators, you can't get them because there's just none available. Manufacturers are doing this like crazy. And, you know, we can't help them all. We're a small company. We have about 25 client-facing people, like Andrew, that do work with clients. We also have support and salespeople and finance. We can't do it all ourselves. So what I would ask, if I could, is that if any of you have a best practice like that in Industry 4.0 or automation, if you have something that you're already doing that you'd like to share in a non-compete way with the community, non-compete way, we've started a program, and not only people that volunteer, but about 25 to 30 companies that we've helped install automation, again, ranging from very simple machine monitoring. We had a client, all they do is print paper on a legacy machine. It was probably 70 years old, big sheets of paper. They don't know how many sheets are in the stacks. They're using a ruler. You know, 20-person company, right? The big change for them was we put a switch on that. There's a +5 voltage. Every time that thing opens up, would poof out a little bit of powder between those sheets to make sure the sheets didn't stick. Just capture that 5-volt signal, give it on an A to D, bring it in, machine monitor it. Now they can tell how many pieces they're making, good and bad. They don't overproduce or underproduce, right? Because if you underproduce, you got to go back in. If you overproduce, you got to throw the garbage, right? Those prints. And then they were able to punch in down codes, and within a very short period of time, they increased their OE from 50% up and running to 80%. That's on the small side. As you go up, collaborative robots, up to the big side, fully integrated systems for control, connecting up machine monitoring right up into your ERP systems for real-time scheduling. If any, we will have tours. Please reach out if you would like to come and see one in Northeast Ohio. We just sort of kicked it off. The tours will be every 6 to 8 weeks. We'll get you all the information. Please come out to one that is like what you'd like to see, not compete. They'll go ahead and screen it. You're welcome to come out. Those will occur all this year and all next year, and as long as people are here. If you have something you'd be willing to share, there's a lot of great things I've seen. I just happened to see a list here from Andrew. Some premier companies on this list that are really moving the needle in a big way in Northeast Ohio. If you have something, if you speak with your staff and they'd be willing to share it and not compete, we'd love to add you to the list. If we all collaborate together, our belief is we can attract more talented workers and keep talented workers ranging from shop floor all the way up to engineers and managers. And if we can do this together. So I'd ask you, if that interests you, please let me know today. I'll be around a little bit, or you can follow up with Andrew. He can get you some information. And thanks so much for coming. The next time you meet, we hope you would come here and use our facility again. That's part of our mission. We will be in a new facility. You may or may not know it. It's going to be up the street at 65th Street in Chester. We've renovated a school. We like to think this is a pretty good facility here, but we're taking a step up in it. We've increased for our engineering staff. They have a much better area to build machinery, custom machinery. That's something that we do. We'll have overhead cranes and all the necessary equipment to really take a step up in terms of amount of consulting we do. Also in the community, there'll be more meeting rooms and meeting space, especially for students, and especially with the little municipal school districts, where they can come in and see the shop in operation. They can't walk in and get in your way while you're building something, right? But they can look through a window, and there'll also be other more up-to-date facilities for hosting groups like this. We'd love to have you there also. So with that, I don't know how much time I had. Hopefully I didn't talk too long. Thank you, Andrew, for inviting me. I really appreciate this. I hope you guys have a great day.
25 years, started in 1996 with Creo-Engineer 16. All of you remember, right? Back in the days, the done, return phase, and currently it's Creo 9. I was in the industry for a good part of my career. Was an analyst as well. I do analysis and Creo, Mechanica, now called Creo Simulate, top-down design service modeling. Back in Ohio, I used to work at Toledo for a company called Glastex. It's been long since I've been to Ohio, and it kind of reminds me of my industry days. Like Rick mentioned, I've worked for Tricer for like 14 years now. My role is a senior applications engineer, so I'm a PTC certified instructor. I do a lot of training on Creo, Windchill, and Creo Simulate. I also help out the sales team from a technical standpoint, right, doing demos. So in the next 45 minutes or an hour or so, I think I have an hour, right, Mike? So my plan was to kind of go over the core enhancements, right? Obviously, with each release, PTC has a lot of, enhancements in different areas. Some of those you may not even have licenses for, right? So, but I wanted to make sure, let's focus on the core usage of Creo, like the usability, right? The user interface, the sketcher, the part modeling, assembly, 2D drawing, all that we regularly use, right? There was a reason why I've not included sheet metal, because there are 0 enhancements in Creo 9 compared to 8, okay? So, if you think about what are the areas that PTC really enhanced, this is a full list. Obviously, I may not, 1 hour is not enough to go through all of them, so I kind of picked up the things that everyday user might need, right? So, so there are quite a lot of areas, right? Core modeling, assembly, all the way to toolkit, ECAD, some new config options to keep adding. So we'll go over all that. I'll focus most of the time on the demo in Creo 9. Usually I'll run through a couple of slides, so I'll switch between the slides. But feel free to stop me at any point of time with any questions, right? Anytime. But I'll be showing most of the enhancements here. So this is what I want to focus on. But some of you, I think, might ask, most of you were on Creo 5 or 6, right? And I don't think some of you are on 8, none of you are 9. So I thought I should give you a quick overview. PTC's moved to a yearly release cycle, I'm sure all of you know. So about 2 months ago, April 20th is when they released Creo 9.0. 9.0, 1.0, the first maintenance date code is going to be released in July, it looks like, and 8.0 is about a year ago. Some of you are already using it. So it kind of gives you the calendar. I just took some screenshots yesterday from PTC's product calendar, so you kind of know. All right, Creo 7, the peak of the pandemic is when it was released April. So you're going to see very minor incremental changes moving forward because there's a yearly release cycle. Compared to back in the days where Creo-Engineer Wildfire or to Creo 2 or from the old iSquare to Wildfire, remember it was a big change, right? You're not going to see that anymore. It's going to be incremental, okay? Windchill, how many of you use Windchill right now to manage your files? So obviously before moving to Creo 9, I personally used to be an admin during my industry days. We don't recommend moving to 9 with 9000 being the first date code. We recommend allowing it to mature, right? But you also have to know what is compatible, so you have to be on Windchill 12.0.2.0, and we could share this PowerPoint with you. This is just a quick matrix of, in order to do Creo 9, as you can see here, Creo 9, you have to have at least 12.0, and that's where it is. You can see that the compatibility chart here, right? So let's get to the main things here. Usability, right? I always talk about the usability first. They did a few things, not a whole lot. Have you noticed when you resize your Creo screen, full screen, or maybe you're switching between multiple monitors, it never remembered when you open another file or a new part, it will never remember the size, the old size, and now it remembers that. So that full screen in one of my sessions in an assembly, I open another part, it will revert the same size. So that's a new minor enhancement there. They've modernized some of the dashboards, as you can see here. This is an NC one where they kind of they've started doing that in Creo 6, Creo 7, where they kind of laid it out a little bit here, and they've done it on NC in augmented reality areas, and also in sensors. There was something called Creo Product Insight extension. They've improved the dashboard. For the users, though, I really like how finally you can look at the license information right from within Creo. Remember the old PTC status? It's still there for the admin or any user to check who is being used. Are there any free licenses or are they being used? Now, right from inside of Creo, where you have your floating licenses checkbox, you can do a license info, and it'll give you, it's very very useful, I think, right? Before admins had to set up that PTC status.patch file for the users, they had to click on it to see it, so I think that's pretty nice. Okay, so a few things. I really like how they structured the options now. See here? I can, appearance, global, core, right? Before it was all in one single list, right? Maybe I'm doing top-down design. I want to set up some control on external reference, for example. I had to go to assembly. Now they know global, right? System appearance, core areas like assembly, those are controlled here. So pretty much the same as before, but I like how it's structured, okay? Now, one minor thing, it's not a major thing, but we have had customers that will ask in some other CAD system, you can use the arrow keys to rotate and spin. Finally, PTC has that now. Creo-RecurDyn, you're able to hold down the shift and use your arrow keys to rotate. Shift and Alt will do the screen center, which is the model center. In fact, let's take a quick look, right? Let me switch to, I had a couple of models open already, right? I have just an assembly here, a data set that I use for my demos. By the way, I'm using Creo-RecurDyn. This is the one I was talking about first. If I go to File Options, see how it's kind of appearance, global, core, right? A little structure, I think, that's not a big deal. If I want to look at my licensing, I can go to File Options, Floating Licenses. Now, I don't have any floating right in there, but at least if I click on License Info, there you go. Remember, in the past, you had to go to PTC status, you had to go to, if you remember how to get to this one, those who've used Creo, you probably know that, right? You go to your C drive or in your admin, the admin has set it up for you, like in my case, I'll kind of show you the old way of doing it. You have to literally go to program files, where I install my FlexNet license server, for example, right? I got my PTC folder here, I got my little FlexNet admin license server, and then you have to go to literally bin, and I used to have a shortcut during my industry days, but there I could go to PTC status, you will run that, and that'll open up kind of like a command prompt with I'm having standalone license, unlike your company, you're all using floating license. So this is kind of how you'll know, right? What is free, what is used, etc. Right? This used to be there for a long time, ever since I can remember. It's been there since the 90s. But I like how you can access that right inside of your file options, right? That's a nice thing, I think. And then it's a minor thing, but you can hold down the Shift key and literally use your arrow keys, right? I know most of us have a 3D mice. How many of you use a 3D mice these days? If you use that, you'll never ever want to go back to a 3-button mouse, right? But you can configure that right in here. I'm just, maybe why do you think this might be helpful, for example, right? Maybe I'm going to some, precise view here. I may want to have some slight precise orientations, right? Before you had to go to view, orient, and there's an arrow key, but now you're able to just use a Shift key and slightly kind of navigate. Can I control that angle? Don't you think it looks like 15 degrees right now? Absolutely. You can go to File, Options, and over there, if I go to my options, under Model Display, there is this default rotation, 50. So maybe I could potentially switch that to 90, right? I can go from front. I remember during my industry days, I used to use VF for view front. There's a Mac key that I used to have. V for view back. You can still do those, right? Those who are fans of map keys, how many of you use map keys, right? Even now, keyboard shortcuts, it's still there. Good old days, right? It reminds me of that. It's nice that they have. So, for example, I'm going to set it to 90 real quick, right? And I'm not going to change my config option here. Let's say I want to go to, let's say one of the front views real quick. Not a big deal, just a regular view like this, right? Front view. I can now be able to go Shift, and if I do this, you see that? I'm using my 90 here. I'm using my arrow up, down keys, right? Which I know most of you may have macros for all this, right? But it's another option there. And then they also, I don't know how beneficial this will be, but you could kind of zoom out a little bit here, or maybe off the screen center. So far, if you notice, everything was a model center. I can hold down the Shift Alt, and then literally right the biking here. So what I'm doing right now is I'm holding down the Shift Alt, where the model center or the screen center becomes my point of reference, and it's rotating off of that, for example, right? So a couple, nothing groundbreaking, I'd say, right, on the usability side, but it's a couple things in there, right? Now, most of you may have used this before in Creo 4. How many of you used the mini toolbar? Right? I'm a huge fan of the mini toolbar, the right mouse click, right? Just long overdue, I thought, in SolidWorks and every other CAD system had it. We were the only one that didn't have a floating toolbar. So I hope you've customized it, right? Config.ui. They used to have a zoom 2 in there before. It's nothing new. But you have a new config option that allows you to control the level of zoom. Where would I use it, right? When you have a failure in assembly or part model with a missing reference, I'd like to go to the reference viewer and zoom 2. But sometimes it's a very tiny missing reference. So I like that config option where it's set to 1. You can set it to 2.0, 3.0, where people control the zoom level compared to there. It's going to go zoom in a little more quicker. So you're not spending your time navigating, right? Now, please remember, moving forward, all config options by PTC will be backported to previous releases. If something is introduced in 9.0, there's a good chance it may be available in the previous release for the later date code, right? Just an FYI, right? So we'll get to sketch on a few things, but let me just get into maybe one of my designs real quick here. So maybe I'll just open up that model here, right? So this is the one I was talking about, the mini toolbar. I'm sure all of you have customized this, right? So you can always right-click customize, and you can always add additional commands there, right? For example, whenever I pick a surface, I want to measure the area. I'm sure all of you know how to do that, right? You just search for area, you simply drag and drop it, right? There's nothing new. I'm just showing you some general tips. In Creo 2.0, 4.0, this is available, right? So I hope all of you are customizing it. Where does it get saved to? Do I lose it once I click Creo? No, it goes to the Creo parametric customization.ui. So it's automatically saved for you, right? Do you guys customize it right now, or have you customized it for quick access, right? That's been there for a long time, right? You can always reset back if you don't want, right? Customized it. But PTC already has this one, right? You go to zoom 2, for example, I click on that guy and hit zoom 2, it will zoom to a certain level. You can control that is what I'm saying. I can just go to, let's say I go back to refit here, I go to my options, for example, and I go to my config. The good old config is still the same. I'm sure many of you use the config.sup, the supervisor config, the local config. There you can go and say, I want to add, for example, zoom _2. You can share the PPT, you don't have to note down all these configs, but they're all available in the PTC site too. But there is, right, the size is 1. I could say, okay, maybe I want to set it to 3. I don't know. Let's see how it looks like, right? I'm going to set it to double the scale there, and now if I go up here and say zoom 2, it goes a little bit inside. Same thing works on reference viewer. I'm sure all of you like the good old reference viewer. What is a reference viewer used for? You can investigate the parent-child relationship when failure happens, right? We all know that. I'm sure all of your experienced users have been there for a while. So you still have the good old parents and children, this feature is in the hot seat. I'm kind of investigating that guy right now. And I can always go into any of these references inside. And this was introduced way back in Creo 4 also, actually, right? You can click on any one of them. Again, yeah, maybe if I go back in here, right click, and I can go to zoom to any one of them and the same thing, right? So it was there even before. So not a big enhancement, but I like some of the usability enhancements there. One of the big ones in Creo 9, I finally got rid of that menu manager for project and offset. I thought it was long overdue, right? Remember, how many of you, I'm sure all of you use the project and offset, right? That's how you build design intent, right? Maybe I want to create an offset, like a group off of that. When they change, it should update, right? We all know that, right? The power of Creo. The problem was, remember that menu manager, this guy here, it'll come with single chain. The flip arrow is always in negative direction. PTC worked on it finally, right? It's more consistent with the regular selection techniques, right? Remember the shift C boundary loop surfaces, many of you may be using it. It's very consistent with that. In fact, it's always a demo is better than a PowerPoint, right? So let me just switch to a model here. I'm going to go to Creo, and let's say I want to go to shading with edges here. Just a simple model we put together. Back in Creo 7, even prior, if I had to go and do a sketch, right? I'm just going to do a sketch real quick on that guy. And there's this good old project Thicken and offset, right? They've all been there for years now. Thicken was introduced in Creo 5.0, Wildfire 5.0, right? All those others were there for a long time. But go to project, you get a new select item. That's new. So if I want to get the entire chain, I just select one edge, hold down the shift, grab the loop. That's it, right? I really like this feature, right? Now, those who are not familiar with this, maybe, but just let me do a quick pause here for a little bit. Before I show the enhancements, I hope most of you know this, right? You can click the C, hold shift, and click the boundary, click the tool shift. I'm sure all of you are doing this right? For quickly capturing surfaces, right? Whether it's for keep and form or for copy surfaces. How did I do that? I picked the C, held down the shift, and grabbed the outside. So fixing everything between the C boundary. Exclusively bound. This is a general truth, right? It's nothing to do in real time. How do you make edges change edge, right? Hold on the shift, and then you can grab this and fix the edge, right? That's the same method is brought into sketching. So you see what I mean, right? The ability to change selection. Back in the days, we used to have the menu manager days. It used to be C boundary, intention, same things are there, just a shift key, right? So let's say that I have to, I'm going to use multi-body here, and I'm going to create another part on top of it. By the way, how many of you use multi-body in Creo 7? Some of you, right? Okay, I'll just create a new extrude here real quick. And let's say I want to go and start creating some, maybe not on that geometry, I want to have an offset plane that I'm going to use real quick so I can literally see. Maybe I want to just sketch on this plane here, right? I have an offset plane where I'm going to quickly do an extrude. And when I'm doing that extrude, what I'm going to do is I'm going to go project. And if I put this edge, you see how it gives you a preview. That's it, right? So I can still do my old school 1x1 chain if I have to, but it's not a good practice. Why? From a referencing standpoint, every edge has an ID. We all know geometry ID. So you cannot replace them quickly. If you pick them as a loop, you have a better chance of failure not happening. This model is more robust to design changes. So that's kind of what we are doing here, right? I can hold down the shift key and get the tangent loop, for example, or I can do the surface loop, right? Or I can say, no, I don't want this as a preview here. I can leave it, I can do the same thing on this one. I can hold down the shift key and get this one, right? So it's a little more consistent now. Some of you may not like the shift thing. You click on this guy here, the details. You can go to the details, and you still have your old school rule-based selection, right? If you want. Remember, this is a button that's available in all features in Creo, right? It's been there for a while. There you can say, okay, I want to have a partial loop or a tangent loop. You don't have to use a shift key itself, but I'm just saying, right? You could. So let's say that I want to get done with this one here. Maybe I want to project it. I want to project one, and maybe I want to use the entire kind of loop there, right? It's one loop. I also want to maybe select, I'm in repeat mode right now. I turn on my repeat. It'll stay. It'll stay there forever until you exit out of it. And I can just pick another guy here. I hold down the shift key, and I keep adding additional ones, right? And I can middle click, get out of it, and keep doing more, or exit this very simple loop that I have, right? And the best part of it, all this is referencing. If I go to my references, you see here it's a complete loop unlike before. That's key. So I can quickly replace it, right? I'm going to show that too. So let's say I got done with that. I'm right-clicking and OK all this, and it's a simple extrude I'm doing. At this point, maybe I want to just drag this guy, and all of you know the shift snap, I hope, right? You can hold down the shift, snap, and you can quickly go up to surface, right? You can just go up to surface in there, right? And you're going to add material here, but I'm going to do a new body, right? I'm going to create a new body here. Let's say if I could, let's see if I could just go the blind depth, actually. And I'm going to just go up to the surface there, right? I created a new solid here, or a new body. As you can see, I got two bodies now, right? I got there's my gusset body, and there's another body here, right? I'm able to go and make it transparent and all that, right? So, but what if I want to kind of replace this edge geometry with this one, or maybe I should have actually added this as my loop, right? This is what I should have added as a loop. I could quickly go into any of those features real quick, do an edit definition here, and I can pick it that way like you normally do, or you could use the references. I'm sure most of you know the edit reference, where you switch references. It's supposed to be a good practice, where it'll highlight all the edges, as you can see here, right? Including the edge you picked and the other edge you picked. I could just say replace that guy with this one and do a little preview, and just like that, the loop worked. Is that making sense? I didn't have to go and pick it again, right? So just a simple example to show you that robustness of the design is kept more when you do the complete loop there, right? So just one small enhancement, I would say. Hopefully all of you like the the new methods of selecting, right? The whole shift key and picking it, right? Oh, this is long overdue, I thought. During my industry days itself, I had put together an enhancement request for this. Have you noticed always the first sketch is huge in Creo? What is the workaround? You have to either change the plane size, right? There's a lot of workarounds. I used to create a dummy circle, hide it in my start part, so everybody will start with a 5 or 10 millimeter an inch model, right? There's several workarounds. Finally, the first weak dimension you change, it will automatically scale, kind of like the old school log scale. It will scale everybody else. So let me show you a demo. It's really only for the first sketch job, right? This is long overdue, I thought, by PTC. So let me create a quick model here, right? I'll just do a new part, right? By the way, it's only for a new part. It doesn't even work when you do edit definition. It's only for the new part, okay? When I'm creating a new part, for example, I'm just doing a very basic new part. Sorry, I'm going a little fast. I want to include as much as possible. I hope the pace is okay. I'm talking fast too, but there's a lot to cover. So I'm going to go into one of my sketches here. I'm going to do a sketch feature here. And let's say I'm going to hide my planes and everything. Right, and I'm going to go and let's say I want to do a quick, I don't know, we'll just, I know it's not a good practice to add a chamfer in the sketch, right? I would have done this as a chamfer, but let's say I'm doing it anyways. Okay, so I just want to show you, there it goes, right? I'm done with it. This is when, remember, the old school method was you had to drag select all the dimensions. Remember that guy, the little modify guy right there? And then you had to do the log scale. So if you change one dimension, everything will proportionally update, right? That was the best practice until Creo 8. Starting Creo 9, why do we still have it? Because you may still have to use it during edit definition. I wish PTC would have made it always like that, but they're making it only for the first feature, okay? So how do you do it now? You don't have to do it that method. You simply, see, just watch the dimensions here, right? What do I have? 269, 142, 150, some really huge values, right? All I have to do, select this guy and set it to 1. Watch what happens to the rest of the weak dimensions. 0.6, 0.53, 0.59, the angle. So it's I thought this is long overdue by PTC, right? Something like this, they do it after a long time and call it an enhancement. That's interesting. So anyway.
Does it affect
that is in Creo 8 itself. When you do a circle, let's say diameter 5, Creo 8 doesn't have so many external. It doesn't go like 100. They fixed it. They kept that one. That's a very good question. Very good question. So what Mike is asking about is when you do your first sketch next to it, have you seen it? You'll always have to zoom out. It's really some huge values. That's being fixed. Yeah. So yeah, hopefully all of you like that one, right? There it is. So very minor in sketches. The big one was project and offset modernized. The auto scale, first sketch. Oh, this is a nice one. They finally have junction. You can pick up a junction or you can pick up an intersection. Before it was overlap, fully closed, open edge entities. Remember the inspection tools? All these were there before, right? Shape, close, tools, highlight. They're all there, nothing new. But what we can do now is let me. Have you tried the highlight overlap before? Many times I would copy an edge 2 times accidentally. It'll be right behind, but it'll never highlight. Have you seen? You drag it and finally it will stay. How about fixing a bug and calling it an enhancement, right, by PTC? So, anyway. So let's just go back, and I'm going to go back to Creo, and I'll just open up some models here. I'm going to go to let's see. This is a demo model I used to show customer sketch regions, right? If you remember, they introduced sketch region, right? I have done I know it's a bad practice. I've done a lot of entities in one sketch. Sketches are supposed to be simple, but let's ignore that for now. It's an educational example, okay? So I'm going to go to this sketch, and let's see if I could do an edit def on that guy. And I'm going to hide my dimensions real quick, my constraints. No, I'm going to hide that so we can reduce the clutter on the screen. They have this new highlight junctions, highlight intersections. Before it used to be overlaps, open ends, and shape closed loops. Remember that? For inspection, right? Before you're exiting the sketch. That has been there for a long time. So what I could do now, let me uncheck everything. If I say show only junctions, it should show these guys in here. See that? But let's say I for the sake of it, I don't care, just whatever, right? I'll just put in some line in there. And if I say I'm going to go show highlighted intersections, it kind of highlights those intersections. Or let's say I had a, I don't know, a line on top of a line or something like that, right? Something like that. Before, when you do the overlap, highlight overlap, have you seen it zoom out, zoom in, it goes away? Or it's not staying, if you remember many of you, I think you're shaking your head. So you've been there, right? Finally stays. It's really, you know what I used to do? I used to go down here, switch to geometry, right? You know, the good old days. And then I used to drag select, and I would double click this guy to select it, and it'll highlight how many lines. It's a pain, right? And finally they have it, right? You shouldn't be spending time. You should be focusing on your design, right? Rather than these, that's my opinion, but anyways. Let me just go back to my presentation here. So I like how they have, you know, so really very easy to remember. 3 things in sketches, right? Offset, project improved, auto scale, and the new inspection tool. That's it. Okay, this is a big one. How many of you are FEA users here? Simulation or Creo Simulate or Mechanica? Some of you. So you do know in simulation, before I talk about this, sometimes you have to apply a load locally, right? It's being held in some location, right? You're mimicking the real world contact. You see what I'm talking about, right? We have to do it local. For the Creo, it's one single geometry, but we have to split it. Creo Simulate and Mechanica had a feature called surface region for a long, long time. However, Creo itself didn't have that. You know, the CAD side. Finally, they have something called split or divide surface. What does that do? A lot of use cases in MBD for appearances. Maybe I want to quickly do an offset, like an emboss feature. Have you tried this? It's doable, but a lot of workarounds to do that. First, you have to do a surface offset, create a sketch, do a project edge. You know, I'm going to show you, demonstrate within the time we have here. I think we're good on time. I will show a lot of use cases. Could be used in FEA, could be used in sheet metal. Mainly, can you see, I want to show the permitted, you know, stamping tool attachment surfaces here. Or maybe in MBD, I'm going to send it to CMM or CAM or an inspection software, or even a step AP242, and when the user or that downstream user clicks on the note, it should highlight those semantic reference, right? That's important. We all know the importance of semantic reference. But now you're able to split surfaces just for appearances and for selecting semantic reference. This is a big one. I would say part modeling in Creo 9, this is the biggest project they worked on. You know, PTC product managers, typically they train us, right? Before they release in January the beta version, they told this has been a long time coming, right? So I thought, I don't know how, even this one, see, even for appearance, can you see here, how did I do this one? You all know in Creo, always a circle is broken into 2 halves. Have you seen that? It's a geometry thing. That cannot be combined, unfortunately. It's still the same way, okay? But at least you're able to unify split surfaces if required, you know? So we'll go through some quick examples, you know? So that's just a high-level overview, but let me quickly switch to Creo, and I think I'm probably in one of those parts that is, makes it the sketch out of that one. Just removing some of my files here. So let's say I have, maybe this one here. I had a few demo files prepped for this one, so I can quickly show you most of those in like 5-10 minutes here, and then we'll move on to assemblies and drawing a little bit. So what I have here is a model. Obviously, it has 2 bodies, right? It has a main body and a fixture body. I've hidden the fixture for now, right? There's a fixture, but we'll get to that. In Creo 9, if I have to split the surface, have you seen every surface? What is this surface really? It's a surface ID. It's a natural surface, right? It's created during the extrude. What if I want to just create a patch for selecting, it could be for applying a specific surface finish or a GTOL, or it could be for aesthetics, right? For applying a texture. All you have to do now is you select that one, and then maybe I'm going to just sketch real quick. We'll sketch something real quick, right? Just do a rectangle, no big deal, just a simple rectangle for now. Done with that rectangle, and while that sketch is selected, this is new divide surface here, right? That's a new enhancement in Creo 9, okay? Now, separate surface region has been there even before. Have you seen sometimes the contour, you do 2 extrudes, it'll be one surface, you can split that, so it can be selected independently. So that's been there for a while. So let me just show from a simple one, and then we'll slowly show you different use cases. I could go divide surface, and I could simply select this, and you see how it's divided in there. I could keep holding Control key, and you see what it's doing. It's projecting and dividing. Right? Is it giving a thickness? Absolutely not. You see that? I don't think it's not a copy surface. It's just split. So it has two IDs now. Is it a good practice to have the original geometry ID to this guy? No, right? You have to, so there is a way to split that or flip the ID, right? You could say, okay, I want to flip the ID because right now if I do a little preview, right up there, right? It's using that as the ID. So I can just go back and resume, and I could say, do you want the original geometry's ID to be on this one or this one? You see how I can split that. So what is going to be our parent surface there, right? If you care about the IDs in there, right? Everything, it's all ID based, as you know, right? So I can go flip it back on here. That's a surface. Now I could just go and say, instead of individual surfaces, how about just selecting the body? And in this case, can you see literally just projected onto and split the entire model based on how it's projected right there, right? So in FEA, we used to do this. This is where the model is being held, right? When I'm doing a test, see, this could be a part that I put in a shaker table test and do a vibration study. How am I going to, not the same example, but that's how we used to use surface regions. I'm glad they have it in the geometry area now, right? So
Is that identified in the model tree?
yes, that's a very good question, as a feature. If I hit OK right now, it will show up as a divide surface. That's what your question is, right? Absolutely. Now, and the ID, there's two IDs now, right? There is a parent surface ID. See, if you do a block and extrude it, why does the ID always count like 54, 45? Because every vertex has an ID, edge has an ID. We all know it's math-based. So this used to have, let's say, ID 59. Now you're going to see an ID 60 or what have you, right? Whatever number it is, there are going to be two IDs. But it's selectable, right? In fact, I can, for now, I'm going to go back to it, redefine it, and I'm going to just say, let's just go with instead of the body, right? You know what, I'll just leave it for now on this surface, right? So it's splitting only some surface in there. You can also use surface regions. In fact, let's see here. Yeah, it's okay. I have a few sketches that I've hidden real quick here. So there it is. All of you know sketch region. How many of you use sketch region? Okay. Starting Creo 5, you no longer have to have fully closed ones. Have you noticed if you shift G, if you go to shift G, it'll switch to geometry. If you go to shift S, it'll switch to sketch region. What is the advantage of it? I can just grab sketch regions. Kind of like in SolidWorks and Inventor, right? Some of you may have used it, where you can grab any sketch region there. They're all regions that can be extruded, right? There it is. I'm going to select these regions, no matter how they're done, and I'm able to go and say, I want to divide, right, this guy, and I want to divide it where it should be on that surface. It should also be on this surface. You see, this is where it's going to be held, or maybe that could be a clamping surface or what have you, that I'm gonna, I can keep doing, right? For example, I could keep selecting the surfaces in there, and I could apply a different color for it or what have you, right? So that's one other, advantage in there of using these features in here. Let me just go hide it. I also have, let's say you want to do maybe a couple of sketches I've already done. Does the sketch have to be closed? Absolutely not. I can have an open sketch like a line. As you can see, I just have a line, and I should be able to divide that guy and say divide it. Now, I want to divide it across all the side surfaces. Those who have done castings, have you used a loop surface selection in Creo? Where you can pick the top, shift, pick the edge, it'll grab all the sides. You shouldn't be wasting time selecting multiple ones. This is a general tips and trick. I'm going to use the same method here if you have not used it. See, I don't want to waste my time picking all the side surfaces. How do you do that? Have you tried in draft? During my casting days, I used to use a lot. You pick the top surface. Have you tried holding the shift and grabbing the edge? That's it. One of the edges. You have to hold down the shift though. You see how it grabs all the others, all the side. Of course, except the one that, since we are already split, you have to do that. So this is called loop surface. You see that? It's called loop. Kind of like the seed and boundary. It's been there for some time, but why would I do this? Maybe I'm going to do some kind of a measurement, a controlled measurement on that guy in CMM, or that's kind of why maybe I'm doing that, right? I want a specific surface patch to be there, right? That could be one reason. So there's several good use cases, I think. So
That looks like a party line.
that looks like a parting line for now, you're right.
Well,
Yeah,
that's the way I put the party line in.
you could put, and then you want to do a draft off of that, right? You're right. Or you could do your old school, what is it, the curve on both sides, or use a quilt. That's all there. But this could be potentially used. Yeah, like that's a good point too. for appearance, or maybe I'm gonna apply
So
some
this
notes.
new feature is very similar to sketching a curve and then doing a
Project, exactly,
But
except,
instead of a curve, it's creating surfaces.
exactly. So you don't have to project. That's a very good point, right? That's a two-step process. You're projecting it, you have a curve, and the surface still remains the same. In this case, it's kind of splitting.
Right.
It's doing two things in one go. You're right. Yep, that's a very good point, yep. Now, what about, let's see, I'm almost, let's say I want to go and do a couple more here. I'll probably just remove some of these, or at least I'll have this one here. How many of you currently do MBD? Model-based definition, or where the drawing becomes optional? I'm not going to say drawing is removed. Drawing becomes optional, where you do all the annotations to the 3D model, right? That's what it is. Can I now add a note? I can go to my annotate using this, and I should be able to add, let's say I want to go, see, for example, this shows the text, the direction, and the direction here, and I could add a note real quick. I could add a leader note, and I could say I want to add a leader note here, something like that, right? So those are, I don't know, permitted clamping surfaces or something like that, right? You see what I'm getting at. So when somebody selects this, I got my 3D notes turned off, there it is, right? I'm able to select, I was in sketch regions, that's why I didn't pick it up. Selects it, I'm able to go to my semantic references here, and as you can see, I could query select as an intent surface. You see what I'm doing? Those who know intent, I picked that as an intent, thereby, if I'm sending this to downstream manufacturing or inspection or a step output, all of you know the step AP242, when you output, anybody clicks on the note, it need not be in Creo, it could be in Creo view instead of windshield. It should highlight that. You see, that's called a semantic reference.
This data isn't lost when you step it out.
Exactly, provided you do step AP242. That's the key. So it's a very good question. So most of you know in Creo, this has been out for a long time though, so anybody does a semantic query. See this guy right here, this little icon? If I do a semantic query, this is not your old school references for attaching, remember. This is semantic reference means this is carried over to downstream areas, right? Consumption. It could be for inspection, CMM, it could be for CAM. And like you said, if somebody wants to export this as step, you would just go file, where is that? Save a copy, as always, that's not changed. And you do your step. However, when you do the step, where is that? You go to your step and go to your options. Remember to select AP242, the best one right now. AP242 can you see annotations are grayed out? This has been there for a long time. Those who have not used it, have you tried setting it to AP242? You can add the annotations and the rich content. So manufacturing, how many of you use CAM or MasterCam or whatever, right? When you send it out to them, when annotations from 3D are passed on, including the surfaces. I think that was your question, right? Does it by default? Please remember to do AP242. That's important, right? So.
Well, what you're saying, I'm learning something here. You're saying that you can actually not have a drawing and put a lot of that pertinent information into the model. And
Yeah.
the first thought is, well, if I export that out into a step file, is all that going to be lost? Because what's the point of doing it if?
Yeah, you're absolutely, that's why when you do AP242, the whole point of why they came up, see, all these are standards, right? All of you know step and IGES, they're all standard. During my industry days, when I bring in a step, it works better than IGES. The loss of data. I always say, SolidWorks sends me, for example, a Creo file, they'll send it a step. It's almost like a rumor going inside this room, right? Two times data gets lost, right? They are sending a step. I am importing the step, so 2 times it gets lost. We will tell SolidWorks didn't import properly, and they will tell Creo didn't import properly, right? That's kind of how it is. But with this AP242, I'm not saying your geometry is going to be airtight, and you may still get those slivers with the issues where it might be open, but at least it takes a rich content, like your GTOLs, your nodes, everything gets carried over. So. You should try it with even a 3D PDF. Have you tried to export a 3D PDF? There also it works, But most softwares, they accept, like CMM or CAM, they accept this one, right? So, yeah, sorry, it's a little bit, I know sorry, I'm speaking fast and going. I always like to throw in a lot of information in a presentation, but sorry, I'll keep going. Hopefully that helped. It looks like, that's kind of how you'll do. Semantic reference. Let me hide some of these real quick. One last example I want to show before I move away from this. So this is why, going back to your question, we have annotate. Why do we have annotate instead of the part model? You can do pretty much all you can do in drawing. Create dimensions, your GTOLs, your datum feature symbol, everything, including show. Remember this guy, flashlight? That's what we do in the 2D drawing. You can do all that in here, okay? All right. I know that's a bigger discussion, right? MBD or MBE, model-based engineering and model-based. I'm sure there are some additional presentations coming up today on MBD, but yeah, that's going to be important. PTC has had annotate since Wildfire 2. How many of you remember? Since Wildfire 2.0, annotate has been there. It's just that they're slowly upping the game. They're slowly allowing more and more features to be included there, okay? So let me get back to the presentation, or actually, one last thing I want to show before I get out of this model, so I can at least talk through some of the remaining one. There it is, right? I have the other file. I know my note failed because I removed that as a reference, but that should be fine. Let me just delete that guy for now. I do have another feature, like the fixture that I'm going to unhide. How many of you use the intersect tool? Anyone? When would I use the intersect, right? Let me, before I explain this, you see sometimes when I go over enhancements, it's nice to see how it has been there for some time. Let me open up this coil. There's a sweep example I usually show to my training. When I train a new user or an experienced user, I usually show this, right? The sweep looks, I'm not using piping or cabling. I can just click on this guy and I can do a sweep. All of you know, right? Sweep is one of the easiest features. You go sketch and you really quickly can go do a circle. There it is, right? And I let me just go and say okay out of that. And pretty straightforward, right? That's a 3D sweep. Now that is cool, but how do they create the 3D curve? That's the question. Let me undo. How is a curve done? During my industry days, I used to have the import the point cloud, you know, the CMM, the PTS file. You would have point clouds and you can create curves. But in this case, don't you think all we really need, viewing in this direction, viewing in this direction, don't you think the way I've done this, it was interesting. Let me hide what I did. I created two sketches. This old school pro engineer trick. You know, you see this sketch here, if I go redefine this and go to sketch view, you have this, in this view, I have my 2D, right? I'm not saying you always do this. You probably use cabling or some routing techniques, but there's a quick technique if you have not used it. If I go to redefine this guy and go to like a sketch view, see I have two 2D views or two 2D sketches. All I have to do now, have you tried ever selecting two sketches and selecting intersect to get to 3D? So what is happening behind the scenes? This is an old pro engineer trick. Whenever I show this, I've seen many users, I wish I knew that type of a thing, right? Maybe, the use case is my design intent is to ensure I show in the 2D drawing the dimensions. That's the key on the side view, right? Now, if it's a pipe, if it's an elbow happening, I would have done it totally differently, right? I'm just doing a quick cable here. There's, you know, just for the sake of it, you're not doing it. You could go, what is happening behind the scenes? Somebody's extruding this guy. Somebody's, you know, I'm saying somebody means, but behind the scenes, this probably is what is happening. Whoops, not edit definition. They're probably extruding the other sketch, the second sketch here, and then you're getting the compound. That's really the intersect. Now let's fast forward to 2021, right, where PTC introduced body. So how about when I have the fixture and the design, can I use the intersect to get those clamping, to get those surfaces being held, or so I could just go use the same intersect, but instead of picking two curves, can I go to query select this and get the entire body? See, I could just go grab the entire body, and I could go, for the other one, I'm going to go grab the fixture body. And now that I have the intersect, if I could hide this guy, the fixture, see how it has created the curve. So that intersect curve, now you know where I'm going with this. I could pick that intersect curve and do my divide of the entire body. Oh, not the surface, whoops. Fast clicking there. So I keep doing right click and get to the body there. And there it is, right? Or I could, you know, I forgot to, let me go back to redefine it and say, okay, I want to go and flip the ID so that I get the new ID on these surfaces, not the outside surfaces there. This could be used for my appearance now, right? I could go to my, where is it, view. I could go to my appearance, and maybe I want to select, that's my tool, whatever, fixture surfaces or what have you, and I'm able to pick. Those who don't like the right click, you still have your good old query selection bin, right? I can pick the intent surface in there, and there it is, right?
So you selected the two bodies, selected intersect, and it generated curves.
Yes.
It wasn't like a cutout or.
No, that's a good question.
Material removal, it just did curves.
You could have, that's a very good point. I could have, instead of doing the curve, I could have done a Boolean operation. So if you're new to multi-body, in Creo 7, PTC introduced multi-body, where you could do a cutout, you could do subtract or intersect. You could have, so there's an interference. Let's say there's an interference fit kind of a, you could remove it, actually. But I didn't use that. I was just showing the intersect curve option. That's why.
Okay. All
Yeah,
right.
but you could have done this. You could have done, I want you to subtract. It's almost like Boolean. We used to do it in merge cutout. Remember the assembly operation?
Yeah.
Multi-body is the way to go now. I should probably send you my presentation on multi-body. I've done an entire one on multi-body that will give you some better use cases where it looks like most of you are new to multi-body because it's only in Creo 7. So in Creo 6 we don't have it, right? So that's a multi-body use case. But yeah, all great questions. So let me get back to, I know I probably spent more time on this than I should have, but got 10 minutes here. Let's keep going here. So a few other things, minor things in there. All of you know the time it takes to pattern, right? Especially, during my industry days, I used to work on these speaker, holes in a speaker, right? Back in the days, we didn't have gig RAMs like these days, right? I'm talking about the 90s, where you just wait, grab a coffee, and it's regenerating 100 out of 245. I remember those days. Now, PTC says you could do a geometry pattern. How many of you do geometry pattern, right? Geometry pattern is like a copy geom rather than the feature definition. It's always lightweight, right? But even that, this is a comparison of Creo 9 versus Creo 8, the number of seconds it took to do a simple one. This is a fill pattern, with identical. When you switch to, all of you know the general versus identical, right? General means it can intersect. It'll be like, what identical is, like the name suggests, it is identical, less regeneration time. It's way faster. So those who have regeneration issues, you should do geometry pattern. Now, I don't know how many of you, the way you're looking, from the feedback here, the way that you're looking, not of people are nodding heads when I ask for geometry pattern, so I should probably quickly show you a quick example if I can. Let's say I open up, this is a normal example I show to customers. See, it is an extrude and a hole. In the real world, these two might be way off here somewhere. They may not be in sequence. I may not be able to group and pattern it. What is the best practice to pattern that? Simply select the seed, shift, grab the outside, let go of the shift. What is this called? Seed boundary. How do I know what I've picked? Right in here. You see that one selected? If I double click on this guy, seed and boundary surfaces. So again, what am I doing here? I'm picking any surface. It doesn't matter which surface I pick. Seed. For example, if I want to pick only these guys in here, I could go to pick seed, shift this, and let go. You see what it's doing? It's just grabbing, the boundaries are cut off. That's what it is, right? I'm using the same methodology to do for all of these, right? I'm going to pick this, shift, select this, let go of the shift. That's it. Having done that, I could do a pattern, but remember, that is not the regular pattern. It's down here. Not sure how many of you have tried it. If you have regular issues in your pattern, please use geometry pattern. It's been there since Wildfire 4.0. It's been there since a Wildfire day. It's nothing new. So I go here and go geometry pattern. I can, oh, by the way, I really like in Creo 6. Have you guys tried the mini toolbar? You no longer have to go up here. This is a Creo 6 enhancement. You no longer have to go up here and use this. Many times what I do nowadays in Creo, I use a full screen mode. In Creo 4, PTC introduced full screen mode. That's how I forced myself into using mini toolbars and right clicks. You should try it. If those are not using mini toolbar, because old habits die hard, right? I myself, a 20-year user from 96, you always keep going there. In fact, PTC has a metric of how much users spend time going back and forth. It all adds up. And I used to manage a team myself, and I asked the engineer, How long are you going to take to design this? All this adds up, you know? The clicks and picks are important in my view. So rather than going up here, try next time, do a full screen. That's it. When you hit full screen, you're forced to use, you know, this has been done Creo 4. If you do the left, see if you mouse over, it'll pop up. If you go up here, it'll pop up, right? And then now that, you know, I'm in the middle of a dashboard here, how do I access the direction pattern? I click somewhere here, there's my direction, axis, and all that. You see how you have, just do a left click, there are multiple mini toolbars, and I could go direction pattern, and I could pick this surface. I would have picked a plane as a better practice, but right now, and I'm gonna go say, let's say I wanna have about, I don't know, 7 or something like that, right? Did I just do a regular pattern here? Absolutely not. It is a copy John pattern, wherein the feature definition is not taking over, so less regeneration time. Now the new enhancement, this has all been there. Whatever I showed you is not new. The new enhancement is, if you were to try it on a much more complex model, remember to go switch it to identical, right? In fact, for the demo, I'll just leave it off without this one, options. There it is, right? Switch to identical. As you know, that's a best practice, right? For faster regeneration time. And it'll be really quick. That's the metric that I showed you here. That's a PTC slide, just to show you, right? They have a video of how fast it is and all that. Those who do rounds and drafts, I know I've got only 5 minutes here, I need to run through this. You have better rounds when they, have you seen before it'll fail if it goes, or have you seen like the sliver surface in an IDIS or a step file where it'll go to a singularity there? Those type of rounds now work, believe it or not. Before, you had to play with the accuracy, have you seen? Or you had to say stop at reference and click on that when you do rounds. So PTC is improving that. Drafts were improved, as you know, in Creo 5, right? With rounds, you can add a draft now, right? That's been improved for some time. But I know I'm going fast and talking fast to you, but I'll get through some of these. And this is a simple one, right? When parent-child relationship fail, remember you used to, back in the days, you used to have like suppress, freeze, quick fix. I'm not about quick fix. Now they have in one dialog box, you can either suppress all or suspend all. If a parent feature is suppressed, quicker access to all the features, and you can say suspend all. You no longer have to go edit, select all, and suspend or suppress. A quicker access. So they're polishing, I would say, some of the UI. Whole config, our customers wanted the ability to automatically pick up the fit, close fit, medium fit, or so they finally have a config for it. Remember, all these will be backported to Creo 7 and 6. Anytime I show a config, they are back. Don't think it's only in 9, okay? Most of them. Some customers didn't want the reset whole node when they make a change. They wanted to be informed. They wanted to, so the default is now no. That way you'll have to go back and hit reset if you make a change, the standard whole node, right? So these are multi-body things which most of you may not have used. Oh yeah, the model tree is improved. They kind of made it a little more toolbar. You see that toolbar type one. You click on the filters. They look a little bit different compared to before. Like how do you filter things? It's the old, you can have a split tree, just like before, layer tree, model tree. If you do a lot of quilts and bodies, multi-bodies, as you can see here, you have a design items tree that PTC introduced in Creo 7. Now they have the ability to search for bodies instead of your model tree, so I'll just skip through. So most of these are, do you all use surfacing? Anybody? A lot of surfacing here, right? If you do surfacing, I've always been to companies where there's 1 or 2 super users that is a surfacing guy. Somebody else tried to edit, they have no clue, right? Merge, there's a lot of few features. Now finally, I like this evolution tree where I can clearly, regardless of the feature regeneration, it highlights what quilt is controlling what feature, and I can go to insert mode. This was there in Creo 7 itself. I have a better organized tree just highlighting quilts, right? Maybe for new users. All of us who have done surfacing, you know what I'm talking about. I can go back and you can do those, so, right? So let's see here. I think, Mike, I have to stop in 2 minutes, right?
Yeah.
So we'll just, maybe I'll quickly run through the last couple of slides in here. Maybe I can send you, assembly not a whole lot, just some very basic ones. You can combine the offset lines and make it a group. Before, you know, the long model tree, when you do exploded lines, you can finally group them. So a few things in there. There's a cool view field. I've wanted to show this, but we ran out of time. It'll kind of show the blocking areas and create a quilt, right? You don't need mannequin, by the way. There's not a mannequin thing. It's a field view analysis. You select the eye of the mannequin, or any data point, that's good, and it'll show the blocking areas. It's a big enhancement in regular assembly mode. Any mannequin, I think, yeah, I'll just, in drawing, the main thing is surface finish is improved, ribbon interface. Other than that, I think it's not a whole lot. Oh yeah, hatching. Remember the hatching? The half, double menu manager finally gone. I call that the baggage of PTC, right? The Unix days, the done, return, finally it's gone. It is a little more ribbon based. If you click, it'll clearly highlight the border. You can right click and keep, it's more user friendly. Let's put it that way. There it is, right? You should try it out, right? Just go to open any drawing in Creo 9, select it, right click. You see, this is your half, double now. Right? So that's a big change. Surface finish and hatching improved, okay? So I think with that, I will probably run my last slide here. Those who are new to Creo 9, please go to Creo reference, and then you have a what's new. I know I just ran through a lot of things in short time. I should have probably reduced the content, but sorry about that. But the what's new has everything in detail. Many of the examples I showed you guys, you can download it right from PTC's help. That's what I did, honestly. Right? I didn't create many of those models, right? I went to PTC's help. What's new? They have YouTube videos these days, right? Everything is there. You can download it and try it out. So that's it. And if you're planning to upgrade to 8 or 9, please go to knowledge base and search for checklist, and it'll give you a checklist link that'll be helpful. Right? This is very useful. For all customers, we recommend it. Go to checklist for updating to Creo 9. It has all the info that you need, okay? All right, so lastly, some of the presentations I did today, we have a lot of webinars that myself and our application engineer team does. They're all available at tristar.com or in our YouTube channel, right? You can view it. But I know we ran out of time, but any quick questions or thoughts? I know I have to, sorry, she's waiting for the next presenter, but any feedback? I know a lot of information. Do you like Creo 9 at a high level? Yeah. Okay?
Yeah, definitely.
All right. So I'll be here, myself and Rick are there. Any questions you have, please let me know, all right? On Creo or Simulate or Windchill, please let us know. But thanks all. Thanks again. Yeah, I should have reduced the content.
It's okay.
Okay, sorry about that.
You want to give them a minute break?
Yeah, if you want
Take a minute
to take a quick biological break for about a minute or so.
while we set up.
Yeah.
You have a,
Yeah, that's not much.
Yeah.
AP 242?
Yes.
Thanks. Hi, good afternoon, everybody. My name's Pete Seike. I'm from SICAM. I'm going to present multi-jet fusion for you today. I'll try to be technical as possible. A quick introduction to SICAM for about 2 minutes, and then we'll go right into the multi-jet. I'll tell you about the process, the materials, applications. I'll show you secondary ops, talk about quantities and size of parts, and also the advantages. So I'll make it as technical as possible. If you have any questions, you can raise your hand and I'll stop, or I may put the question off to the end, and then we'll do question and answers at the end also. So with that, let me get started. That's where I live in New Jersey. At SICAM, we've been in business since 30 years ago. We started as a service bureau doing 3D printing. We had the 11th stereolithography printer in the world back then, and not too many people had a solid model back then to put into the machine. So we took a long time for 3D printing to start, but now everybody knows about 3D printing. And what I'm going to talk about is the multi-jet fusion technology. Our company still does a lot of services. Our client base is very large. People send us files and we do a lot of printing for them. We also do manufacturing, and we do a bunch of other services also. We have locations here in the US and in China. And our client base, we help every type of company you can think, from aerospace to medical, telecommunications. So with that introduction, let's get down to the multi-jet. So this technology is invented by Hewlett-Packard. When we all started in the industry and we made prototypes, and everybody knows about the wire machines, the FDM, and the MakerBots at your house, and it makes prototypes, and there's plus and minuses about all the prototypes. This technology is the first technology that came out, in my mind, I wish I had it 20 years ago, to make direct parts for low volume manufacturing. Everybody's talking about additive manufacturing. Well, some of the parts that we make, and you're going to see some examples here, it makes a part out of nylon. This is a keychain clip that I'll be giving away. You can stop by the booth and get a free one. This is a nylon part that's printed, and you could print 1,000 of these overnight. No tooling. So the real advantages of additive manufacturing is being able to produce a part that you can use for direct manufacturing. And that's what this is about. The technology is, we were all waiting for HP. They said, oh, HP is going to come out with a printer that could do 3D printing like your copy machine. And everybody thought everybody had one in the house. Well, they never did that. They came out with a production machine. That came out 4.5 years ago. So we're going into our 5th year. And when it first came out, that's $500,000 to set that up right there. The printer's about $200,000. But the support equipment's another $300,000, and then you can be in the business of printing low-volume production parts. That's the equipment that we have. It's the printer, and there's a thing called the build unit, which you see at the bottom there, and then a processing station. So how the process works is that build unit is a 15 by 14 by 12, somewhere you'll see cube. It's filled with nylon powder. You take it out of the build station after you fill it, you roll it into the printer, and then you start printing. You take the other one out from the night before, goes into a cool down area, and after it cools down, you put it back into the processing station, you take the parts out. I'm going to show you how that gets done. So it is a powder process of nylon. It fuses the parts together by melting the nylon and the fusing agent. It's very high resolution, and it does thermoplastic materials like injection molded materials. So you could use it, it was developed for short run production, but you could also use it for prototyping. So how does the machine work? Inside the machine in the build chamber, it has a wiper that goes front to back, and another wiper that goes left to right. So the front to back wiper up top here is the one that lays the powder down. Lays it down to a very fine layer over the previous layer that it built. After it lays the powder down, the other print head comes across the top of the thing in 10 seconds, and drops the fusing agent and prints like a copy machine does. Laser jet, prints right down onto the powder. After it passes and it prints down on the powder, it looks like this. The heat lamp goes back the other direction, and it fuses the material where it dropped down onto the powder. And that's what a fused layer looks like. Then the machine goes back and forth and recoats the next layer. So layer by layer, it fuses the material. Now, I say high resolution. The X and Y of those droplets it drops down is less than 1,000th in diameter. It's 8/10. So the droplets are very fine. The Z height of the layering that you see in most printers, 3D printers, is under 3,000. It's close to 2,500 layers. So the grow lines on the model that you made are very fine. A lot of the wire machines, you know, the grow lines are 10,000ths. They look very rough. So the parts that come out of the machine have very crisp corners and edges. So I have a bunch of these parts outside. You can come take a look at the details of them. You can get a free keychain and see it. Some of you's already stopped by my booth already and saw this. But you'll see it's very fine resolution. It looks like the part's almost injection mold. When it comes out of the machine, the build station gets pushed back into the processing station. And how do you get the parts out of the machine that has this big 15-thing chamber of powder with parts that were cured inside that powder? You vacuum it out. The operator has to sit there with a vacuum on the processing station about 20 minutes to get all the parts out of the build station. And when they come out with powder on them. You can't get all the powder off. So you see these parts over here to the left, they're gears. You see a lot of powder around them. Now HP wasn't too good at telling us how to clean that powder off when we bought the machine. Because they said, oh, get a sandblaster or a grit blaster, do it by hand in a chamber. So we had operators putting them in there, spraying them with the gun, clean them. It took forever. I said to my partner, we're not going to make any money at this, doing it at that level. Well, he found a piece of equipment that was developed for another powder process in Germany, where you take all those parts in that shape, you put it in this machine that has a tumbler and a vacuuming and a spray system automatically. And we could do all the parts that were in that build chamber within 20 minutes. It cleans them. And it cleans them to this level here. So the parts, you see some of them out on the shop bench. They're gray in color. So if someone says to you, well, you print these parts, give me 50 of them. What color can I get? Gray. Now, you can dye them black. That's what HP developed. So we do have a dyeing station. So you can take those gray parts and you can put them into the dyeing machine and you can end up with black parts. So that's basically how the process works. Now the materials. When we first got the machine 4 years ago, we only had PA12. It's a nylon. And we ran PA12 for a long time. Then they gave us the PA12 glass bead. And then after the PA12 glass bead, they gave us PA11. And these materials are available. Then they came out with people wanted a flexible part. So they came out with a TPU, plastic urethane, and we can make rubbery type parts now. Then they came out with a polypropylene. Polypropylene material is still in development. When they release these materials, it takes about 6 months to a year before they get perfected. Because we get feedback from the materials of how good they work and what problems we're having with them. Polypropylene is used, but I'd say it's about 90% equal to injection molding polypropylene. So there's the process, there's the materials. So what else do we do with the parts? What else can you get from them? What kind of finishes? So the process is the flat gray, as I showed you on the left. when we dye in black or natural gray, we created a shot sheen process, the one I told you about with the vacuum machine, and it blasts the part. And a lot of people are trying to blast the part by hand in the chambers that I told you about. They put the gloves on and they kind of clean the part. It's very labor intensive. Not only is it labor intensive, but it's up to the person about, it's a manual operation. So if there's a hole there and he doesn't blast it properly, you won't get the powder out of the hole. People deliver parts, they say, hey, the hole's got powder in it. We developed an automated process called the shot sheen that we trademarked, and our parts come out perfectly clean. All the powder's removed from them. So the standard part that you can buy from us is a shot sheen finish. It's a textured finish, black or gray. Now, after that, we developed another process called the vapor smoothing process. It's a chemical vapor machine, and what it does is it takes the surface and it chemically hits it. It actually melts the nylon's surface finish and causes the part to seal even better and harder. So for water applications, that vapor smooth process is pretty amazing. I mean, we're doing one project right now that I could just tell you generally about because of the confidentiality. It's a manifold that does water through it. Very complex manifold. You can't make, yes?
Any restrictions on undercuts or other geometries?
Nope, I'm going to talk to you about that in a minute, about the design for freedom. That's another advantage we're going to get into in a little bit. But getting back to this water application, it was a pretty amazing project. The vapor smoothing process is what really solved the problem because any plastic is porous to some level. It'll take water on it over time and swell. When you vapor smooth the parts, it seals the part. So for water applications, it's really a big advantage. So we offer vapor smoothing. Then some of my customers said, this stuff's so great, you know, I need a blue part. Can you paint them? So yeah, we developed a painting process where we put a light few thousandths paint coats on, and we can paint the parts. There's some examples of it out on the bench out there. So that's what you could do. The only other finishes that we developed was the plating and the vacuum metallizing. But we could do that in any of our 3D printed parts, the vacuum metallizing or the plating. So there's what you do for finishes. So, let's talk applications. What are people doing with this? I didn't know when we got the machine what it was going to do. I thought one of the best things about it was that we would be able to make a volume of parts for somebody quickly. Low volume, manufacturing. So I wonder, well, how many can we make? I'm going to show you some slides after this. I'll get into the details of how many I build overnight, what sizes. But, you know, we're wondering, what are we going to do with this thing? Well, believe it or not, SICAM has thousands of customers. We've been doing 3D printing since 1990. I got clients that have been with me that long. They go to my website, throw files on, and get quotes instantly, and they order parts automatically over the website. And they've been buying prototypes from me for a long time. Well, guess what? When we brought the machine out, told them about it, they were all buying prototypes. And no one was buying manufacturing parts. So I'm telling them, well, you could prototype with the machine. And they're going, this is great. I could get 50 sets of parts instead of, because the wire machines take forever to make 50 parts. The SLAs take forever to clean and make 50 parts. You can make 50 parts overnight with this machine. So they started prototyping with it right away. And I was saying to them, well, that's not what we bought the machine for. We really bought it to do for manufacturing. But what I found was most of my clients were high volume clients. They designed injection molded parts. And that's what they were prototyping. Now, they made 30,000 or 12,000 or 10,000 parts a year with injection molding them. They weren't going to print 12,000 parts on this machine. So what I found the market was, it was for companies that used to just do prototyping with me and did low volume, like for example, I have one medical client, they make imaging machines. They only make like 300 machines a year. They charge $1 million for the machine. but they don't sell 30,000 of these machines. They only need 300 a year. Well, guess where they get their parts from? They can't afford to build an injection mold, so they're machining all their parts. These are customers that the engineers I wasn't talking to about 3D printing because they weren't prototype. They're going to machine shops and saying, machine me 30 parts. Well, now I got purchasing people calling me saying, I'm telling them, look, you don't have to machine anymore. You can print the part cheaper than machining it. So that's one market. The application is short-run production. And I'm going to talk to you about the quantities that you can do and where that market is. But one of the thought processes is in making parts, instead of CNC machining parts, printing the parts. Now, most people at CNC plastic parts use Delrin. That's a nylon. So if any of you do CNC machining of Delrin parts, low volume, 50 to 1,000 to 500 a year, you don't have to machine them anymore, you can print them now. The other thing that's happening is I'm finding that my clients that do the high volume stuff, all of a sudden they came to me a few years ago and they say, you know, we could pilot run a new product without building the molds and see if it sells. So there's another application. Pilot production. I got a client up in New England right now who's doing 10 sets of models a month. And he started at 20, now he's at 30. And he's getting to the point where the product's taken off and now they're going to tool up the product. So I've been doing production for them for the last 3 months. He said maybe another 6 months of production with you, and then we're going to go to tooling. So there's a pilot production run, and then they go to manufacturing tool. So that's direct manufacturing where it's at right now. Although you still could do prototyping with it. The design freedom, that's what you talked about, the design freedom. I got parts out there to show you. You could design parts like this chassis over here. This is for an aerospace chassis. I don't know, they order 25 every 3 months. 100 parts a year. They no longer machine them, they just print them. This one here is a fixture. It used to be aluminum, they went to plastic for a fixture. Now the problem with going from metal to plastic is you have to learn how to design to do that. Because it's not it's a removal of material, you're adding the material. So for example, all this solid material in here is wasting time for a printer. So when you redesign it, you design it so you have ribs in there, less material for printing. Another application is all kinds of manufacturing tooling for fixtures. A lot of robot head handles. Used to machine fingers for a robot to grab onto their products. Now they just send us files and we print 3 fingers, they put them on the robot and use them. So there's your applications. There's another area, assemblies. You can make assembly models. Models put together and print them all at one time. That's not a big application. People are trying to do that. And but the real advantage is in short run production. That's where I'm seeing customers move in that direction. What secondary operations we do? Most people ask about tolerances. Tolerances are a problem. If you CNC machine a part and then you want to print it, you're not going to get CNC technology tolerances. Now you don't need plus or minus 1,000 or 3 thousandths in a lot of areas on the outside of the part for a CNC machine. Can it cut it within 5 thousandths? Yeah. But you don't need that. You only need it in critical areas. So the tolerances on this process anywhere from 5 to 10 thousandths as an average. You're not going to get any tighter than that.
Is it based on size of part, length?
It's based on geometry. It's a heat process. So there's a lot of complications that I can tell you about the technology if you bought it and tried to run it. I got engineers that have been doing it for 4 years now. We got it down to a science. But it is a very difficult process to control. It's done with heat. And depending upon how you stack those parts in the cube and how close you put them, the amount of heat it builds up. And if you don't do it right, your tolerance is going to grow on you. So it's really geometry dependent and the way you set up the process.
But you could like machine the part.
We do a lot of secondary
after
machining.
Secondary machine.
A lot of reaming,
Right.
a lot of reaming, a lot of inserts. We put, in molding, a lot of people that injection mold, they do inserts in the part. So we do a lot of inserts. We do a lot of reaming, tapping, not too much milling and turning, but if you had a tight pocket that had a chamfer in it down there and a counter bore, and that had to be held within plus or minus 1, you got to go in there and clean that pocket up. So that's the secondary operations. Let's talk about quantity and size. So here's where you look at the process, and you got a 15 by 11 by 15 cube. Actual numbers are 14.96, but it's pretty close to 15 by 11 by 15. So as many parts as you could stuff in that build and how you position those parts is critical to how many you're going to process. And it goes anywhere from 6 hours to 12 or 16 hours, basically overnight. We run it on the high end because I got so many clients that send files in. We're running the machine full bore. You really don't want to run it for only 2 hours and only build maybe this high in that build. So
Does that include support, or is
there are no supports.
there's no
It's
support?
a powder
It's
process.
just multi-jet.
The part, wherever it's cured in that powdered cube, it's exactly where it stays.
Any material nonlinearities in terms of directionality or?
No, that's not so much the material. Each material runs differently naturally. So you have to learn those parameters to use. But the direction, the direction is critical in some areas. So believe it or not, I thought you would just lay a part flat on the table. Sometimes that's not the case. You got to tilt it.
Any shrink or warpage?
Yeah, there's shrink and warpage. Yes, there is. You have to know all about that. Now, I don't have the details of it. I am one of the company's co-owners, but I have engineers that have been with me for a long time. They know, my partner runs the operations. I handle sales and marketing. You know I'm an engineer, like you guys. What's that? I'm sorry?
We trust you.
Yeah. But it is something you have to learn how to use if you buy a machine and want to run it.
Does it do hollow parts? Hollow?
Great question. You have to put holes in it to get the powder out and then reseal them. I'm running a little bit fast on time here, so I'm going to move it a little bit forward on you. So basically, how you put the parts in the build chamber and the size is critical, okay? This is the clip. 2 parts, female and male clip. Here they are. 1,232 of these clips I could do overnight. 600 of one, 616 of the other. 45 of these parts, 19 of 26. If you have large parts, you're only going to do a few. Costs. It costs X amount of money to run that cube overnight. If you do 1,500 of these, you pay $3 a piece. It's $1.50 a part, which isn't too bad. Because they're small. So small parts are very inexpensive to run, and you can run higher quantities. These parts are going to cost you $300 a piece for that fan blade. Now, I don't think you're going to machine that fan blade for $300, but you can make it for $300 and print it. And then naturally, 50 to 75 for that part. But so basically, one of the things you have to realize about the technology is it's not going to give you high volume. It's really a low volume manufacturing process. Small parts you're going to be able to print between 25 and 1,500. So if you do 3,000 pieces, you can run it twice a year that way.
In the 30 years you've been watching this happen, obviously the biggest thing is the cycle time. What it takes to make this, because everyone else is going to compare it to high production tooling. So in the 30 years that you've participated in this, how closer has the 3D printing come to reducing its cycle time where it might need 3 hours to grow a part, where an injection mold's popping 30.
That's a great question.
In 30 seconds.
So I'll try to give you an answer, a general answer on that. The better way to look at it is, I'm finally in a position where I can say to my customers, look, I can make you parts that you can put on an actual product and sell. And he's gonna say, well, how many can you make for me and what cost would it be? And for these low volume parts, you know, I could build a mold, 2-cavity mold for these 2 features for about $8,000. Turn finished cost, $8 grand. $6,000 to $8,000, 2-cavity mold. Okay? So if you only need 500 of these a year, this size part, okay, you have to go 4 or 5 years to pay for that $8,000. So you could run these parts for 4 or 5 years before you justify buying a mold. So the smaller the parts, the break-even point before you buy a mold is up here. The larger parts are lower, are different costs. For example, that fan blade there, that's 11 inches in diameter. That's a $16,000 mold, by the way. And that's pretty cheap at my China tool. That's been built in my China factory. You know, you do it domestically, they're charging $25,000 for that mold. So I could make you a part for $400. You know, so 10 parts is $4 grand. You may be able to only have 25. You can justify at 50. You might as well buy a mold. So that's where that large parts end up here at 50.
Yeah.
So at some point you're going to be able to purchase the tooling. So if you look at that picture that I'm showing you, the real thing is that you're doing low volume, very low volume.
Well, my question was more directed towards that fan, for example. 25 years ago, it might have taken 18 hours to grow that.
Oh, absolutely.
Today,
I mean, if that's your question.
Today, it might take 30 minutes. So
Yeah.
you're seeing a day and a half drop down to 30 minutes, even though an injection mold might pop it out in 30 seconds.
That's correct. So the thing is that you're getting at is that with 3D printing, okay, you could run 4 of those overnight, where it would take maybe 4 or 5 days to run. But the small parts are like night and day. I mean, you could print 1,500 of these. You're not going to print 1,500 on my stereolithography technology or my FDM technology or even Object. Any of those other technologies are going to take a long time.
So you're saying multi-jet is
Fast.
even faster than the other known standards that we've seen for 20 years?
Absolutely. That's one of the biggest advantages.
Kind of dovetailing with this question, what's the lead time and turnaround? If I have
2 to 4 days.
Okay.
Why 2 days? I'll tell you what. You see this key here? I run your batch tonight, right? It's got to go to a cool down process for a whole 16 hours. So the second day it's cooling down. We don't ship it till after the second day. So the fastest you're going to get something is 2 days. Now, with production, you know, they don't need it for, they're not looking for 2 to 4 day delivery for production. They're looking like for 3 or 4 weeks. I don't need the parts for a month, but I need them next run in 2 months from now. I need a batch run again. So with production, we're finding that it's prototyping is what they're looking for real quick. Production, it's pretty amazing that we're doing production. I'm doing production jobs in 2 to 4 weeks that take 8 to 10 weeks lead time. So the fast delivery is one of the areas. Functional prototyping still, as I mentioned, short run and pilot production is the real big advantage of this. No tooling. If you're buying these parts to put on products and sell it, you don't have to buy an injection mold. There's no tooling. Injection molded quality, you're getting thermoplastic materials. You do have design freedoms, and I'm starting to see that happening now. And that is only advantageous to the people that have the low volume need. They're not gonna, if they're gonna tool up later, you can't design a part you can't mold. So design freedom's there, the fast delivery, and truly it is, I'm doing a lot of work for government projects now. All my government contractors are going crazy with me because the government likes to order 25 parts they're gonna put on a drone. They go on a drone, they buy 25 at a time. They build 25 drones at a time. They don't want any inventory. So it's truly just-in-time manufacturing. You don't have to store parts on the shelf. So that's basically my presentation. And love to talk to any of you. I'm just hoping I'm at my time frame here.
You're okay, we're.
So if you have any other questions, I could
Flexibility, if
answer,
there's any
come
questions
out
from
and talk
anybody.
more detail.
I can see where this would be very valuable. While your tooling is being made, you're getting production parts in that 16 to 20 weeks. Then you cut off this and you go to your production tooling.
Absolutely,
All during that time, you're.
absolutely. I have some clients who are doing that, and you know what, they say, oh, I only need it for 3 or 4 weeks for you, 6 weeks for you. And then 6 weeks comes, guess what? The mold got delayed. The mold ain't gonna be done for another 3 weeks. Give me more parts for the 3 weeks.
I think another advantage is you can quickly iterate. If you find something wrong.
That's a good point, I didn't even think of
design,
that.
you can
I didn't even think
quickly-
about talking about that, but you're right. The one thing about this technology, I tell my clients, look, you could prototype it here, get, oh, I want 50 parts. Well, maybe you should build one first real quick, or 2, 5, and test them. Oh, they build the 5, they go, gee, I'm glad we did that, because we didn't get the 50. I gotta change this little ribbon here. That's your point.
Yeah.
We'll definitely come up. Oh,
I just one more question.
Sure.
I sort of, I don't understand why, I call it the grow box, the 15 by 12 by 14, whatever it might be. Why over 30 years has that box not become bigger?
Oh, it has, but not in this technology. I mean, I've seen the wire machines at 40 inches by 40 by 40 cubes. They place down a layer at a time with a wire head. It's very slow.
Okay.
And what happens is they build the part that big and they get 3/4 of the way up and it crashes. Now they just spent 4 days trying to build a 4 foot by 4 foot part. And they gotta take it off the platform and throw it out and do it over again. So the machine itself, and I have all the machines, they don't run 100% all the time, they break down too once in a while.
fantastic.
So, oh, by the way, we're giving away a chess set in the raffle. Come put your business card or fill it out over there at our booth, and we're picking later on today for the raffle.
Fantastic.
And stop by and see. Thanks a lot. Thanks for having me. I hope they enjoy it. You gotta shut that.
Someone in here by DDS? Okay, everybody. As you can see, we're going to be talking about Creo Freeform, using it in an industrial design application. Our good friends from PDSVision are going to be doing the presentation, and it's all yours.
All right, thanks guys. We're going to have Keith presenting on Creo Freeform surfacing today. You want to do the next slide? Just a quick overview. Keith, you want to kind of talk to what you're going to be showing today?
Hi everyone, I'm Keith Morris. I'm a CAD specialist with PDSVision. Just to give you a real quick background on myself, I have experience in 3D modeling, animation, and CAD design, as well as more of a design experience and freeform modeling. And so I also have a background in 3D printing, so the last guy that was up, a lot of that was ringing a bell. Yeah, skip that.
So I'll just touch really quickly on who PDSVision is. We rebranded in January. We're Boundary Systems. Switched from blue to purple because of our Swedish ownership. They're headquartered out of Sweden. Boundary Systems, now PDSVision US, is still headquartered here in Cleveland, Ohio. I know a lot of you guys have been down to our training facility down in Middleburg Heights. We're PTC's largest training partner in the US right now, which we take a lot of pride on. Mario's attended a number of our classes. So, all right, next slide. So just a little history. Boundary Systems was founded, just off the Detroit Shoreway back in 2006, over in Cleveland West Side, and back in 2018, you can see the purchase by the PDSVision Group, and ever since 2018, we've just been operating as Boundary Systems, a PDSVision company, and now officially the rebrand. PDSVision also just acquired another reseller in the U.S. Based out of the kind of primarily Western United States, Sconce. I'm not sure if anyone here is familiar with them, but we're still kind of operating independently, but I'm sure at some point that'll kind of start merging together. All right, next slide. Just a few other products outside of PTC. I know a lot of people are generally pretty familiar with Keyshot, 3D rendering software. ZWCAD is a kind of a cheap 2D CAD player that people use. Moldex 3D, plastic injection molding. Xformation is used for license monitoring, not just specifically Creo, but SolidWorks and all that. So a couple nice tools. What we've really been pushing through COVID and things is the digital thread. A lot of companies are moving towards trying to keep paper completely out of their facilities, and one of the ways they're doing this is, each department has a CAD software or an ERP tool, and you kind of work in your own silos. Your department interacting, and then all of a sudden when you're switching to production, you're sending an email. So maybe your design unit's nice and tight and everything's on the computer, but then when you move departments, all of a sudden you're sending an email, and that process is becoming harder to track, or you're walking down the hallway. This is kind of an example of that. And then on our next slide, this is kind of the way we really like to look at it. A lot of companies that we'll walk into and start working with, they'll have a CAD tool, a lot of times Creo, and they'll be interested in document management, or they'll be running document management, and they'll be using Windchill as a CAD tool. You kind of put a circle around CAD, a circle around CAD management, and then they're interested in document management, or they're interested in moving it to the cloud. And so you got each kind of aspects of PTC's kind of full life cycle digital thread up there. We find this is a pretty helpful tool. But with that, we'll get back to Creo. If anyone has questions about any of the dots, I'd love to talk to you. I mean, I know ERP integrations are hot topics. Again, yeah, moving to Boundary Systems Cloud or PTC's cloud. We'd love to discuss that. Everyone enjoy the presentation.
All right, so I don't know how many of you are familiar with a key specific tool inside of Creo, which is called Freestyle. We said Freeform earlier. If you are, maybe you can fall asleep now, but I'm assuming most of you are not. So what this offers is, this is not your traditional sense of building a model or a part. What it allows you to do right off the bat is take a three-dimensional shape and immediately start modeling it and molding it right off the bat. You do not have to create any planes and attach them or connect them. You can just take a shape and literally start sculpting. This allows you to give a lot more high quality areas, higher geometry, higher tessellation, whatever you want to call it, and you don't have to worry about patch structure. It's just you're starting from a sphere, cube, cylinder, and you can push and pull, cut, extrude, inset. All of that is within all those tools are within Freestyle. These are just some examples. To me that looks like a Viper up there, but the wireframe view here just gives you an idea of how far you could really take that tool. And then on the bottom is a really cool space shoe. I think it looks like a space shoe, but it gives you the idea of especially on the left with that wireframe view, it gives you an idea of how far you can really take it. And on the right are high quality renders out of Keyshot. As I mentioned, they are developed and created organically. That's a good word choice, because this may not be something you use necessarily for like a mechanical or a hard or rigid part, but even those you can add those types of features and then take it back into what you are used to. So you can, at some point, I'm sure even before that first one on the left, it probably even started from a cube. And then as it progressed, you can literally just start pushing and pulling and adding certain features to it, and then eventually it gets to the highest tessellation and allows for the highest quality. So it's for a lot of parts that may have ergonomic design to it, a lot of curvature. I've heard the nickname swoopy, but yeah, it allows for those types of designs. And I'm gonna just start and just to give you a real quick crash course on this. I'm not gonna do anything super, because since we only have like 20 minutes, but I'm not gonna do anything that's finished. But what I would like to do is show you, I'm gonna turn those off. What I would like to show you is just kind of how you can very easily create and start a concept. So all the way over here on the right where it says Freestyle, that's where you want to start with. And then up here on the top left is where you can select any, there's 4 basic shapes here, but it's whatever you think. I do want to point out there's going to be different ways you guys approach this. There's going to be different, everyone works a little bit differently, and it also obviously depends on what you're going to model. I'm just going to start to design like a smart remote, like a TV remote or a Bluetooth speaker remote. And I was doing this earlier today, and I started with the cylinder. So right off the bat, I'm just going to start. I'm just going to start getting the basic shape down in here and start just pushing and pulling. And you guys will be, I don't have to explain a few of these things, but I am able to tessellate or create more subdivisions onto this model. So right here, I just want to split this in half, and so I can choose to have 2 edges, 3 edges, and beyond. For now, I'm just going to put 2 there, and then I'm going to take this. And I know I have kind of the boundary around it, but as you can see, it's already creating this smooth surface right here, just by literally just taking it and pulling it. I'm going to take this and tuck it under, take this, push it up. Whoops, I did not mean to do that.
Now, can you assign numerical values to how much you want to push something in?
No, this is just strictly about just taking the model and pushing, pulling, and moving it to the way you want it to be.
You can though, if you say from the bottom you want it to be 1/8 of an inch higher, you could have an offset datum plane, and then you can actually align it to the datum plane.
Okay, so there's ways to get around it.
Yes.
Yeah. So I'm just gonna select. You can. I'm gonna do this. Technically, I could split it and then mirror it, but this for me, because it's just getting the basic shape down. This is just a little bit easier to just change the scale or the position of those 2 corners I just selected. I'm gonna switch it and just pull that out some. I'm gonna do the same thing down here and just move it in. So, and then I'm going to create another edge along that area. Another one, another. So, I'm going to pull this up too. But this is, you mentioned numerical values. Yeah, as you get further along into the model, you will eventually get into finer ways to get, certain details of your model. But this is really just starting to, this is just demonstrating just getting the basic shape down if it has a lot of curvatures and a lot of areas where it needs to get to the point where you're saving a lot of time by just starting with a shape like this.
So it's more industrial design, conceptual design.
Yes.
Yeah.
I mean, and not to say that they had, this can eventually be, turned into a final part, but this is just a lot quicker way to get the concept down.
Can you have a reference model in this assembly where you can see how this thing you're building relates to something else, or is it just one thing at a time?
You could put an assembly together and have this as one part, and then have the other part as like a template. One of the things too, and we started with a 3D primitive. There's also 2D primitives, so you could have like a sort of like a trace sketch, if you will, bring in an image, scale it appropriately, and then start with a flat, and then flesh it out from there. There's a different combination.
Yeah. I do want to say this is not the questions that have been asked already. I just want to say any other questions we have. We're also outside there afterwards as well. So feel free to stop by, and any further questions you can ask us there too. So one thing I wanted to do was also start to create a button. Oh, before I do that, I wanted to show you one quick thing. So if I wanted to get if I wanted to get these edges, smooth all the way around, I could just select the whole model, and there's this crease tab right here in the ribbon, and you can choose to, I'm gonna switch to soft, and I'm not even gonna, I'd be happy with that right there, but you can increase or decrease as you see fit, and then already it's just, I don't even have to add more edges to create that. It just automatically does it just by selecting the whole thing and choosing that. I know this isn't exactly looking like a remote, but as I continue to push and pull and drag it, you know, it eventually would. One thing here too is if I were to start creating, if I wanted to create a, say like if I want to start creating buttons, I could take the face there, and there's different levels of insets here, so I want to do 2 of them because I want to create where it looks like the button is sitting in, it's nesting kind of in like the groove. So I just want to start with this one. And before I move it, this crease is selected on hard. I just want to kind of turn it up higher and then move it down. I could keep it as an oval, or I could make it like a circle if I changed it back to scale and I moved it out some. And then I want to do an inset again, but I want to put it here. And then I'm just going to push it up like this, and then it'll start to look like a button. And as I'm tessellating and going throughout, you know, I could add smaller buttons. I could add more like towards the top. Like a lot of them have like. A lot of the newer ones have like a larger central one towards the top, and then the smaller ones towards the bottom. And the reason I chose a remote is because it's you know, that's just a simple design. There's, you know, it gets down to the basics there. So I don't. You can. I want this longer. This whole end here. I don't want to work too much in this right now. I just wanted to show you like the concept of sculpting and pushing and pulling and creating a very quick concept that you don't have to spend. It takes out the tediousness of building that kind of surface in the traditional way. So I'm just gonna leave with that. And if you want to learn, you can learn that more in depth. We do offer training webinars for that specifically, and we have, you know, myself and other certified trainers that can dive deeper into that. Training is available, and it's still available virtually if you still prefer that, but we can come to you or you can come to us. Our website does offer the full schedule. Technical questions, my email's right there, and any sales questions is the email there, and our website's there, and we're also on YouTube. Thank you guys for your time.
How does this compare to like a Rhino type software?
That's like, I don't know a whole lot about Rhino, but I believe with this, since you're able to just start with a shape and immediately, whereas with Rhino, I believe that feature is not in there, that's not,
Yeah, so one of the benefits of that, just to jump in, I'm part of Keith's team here, is that the benefit of using this tool in Creo is that it's difficult to take information modeled from Rhinoceros and Maya software like that and import that into Creo and work with that model. Whereas if you have this model started within Creo, it's easier to work with that as far as your workflow, adjusting the model, trimming it, up and down. So it's native to Creo.
Right. It is a quilt. You can solidify it after you get it kind of to the desired shape. So then you can add solid features in there. You can, cuts and whatever you need to do with it.
Shell it out,
Yep.
thicken it.
You can't probably 3D print from this software, but you move it into Creo and then
You're in
solidify
Creo.
it.
It's a Creo feature.
So you can 3D print
Yeah.
that shape you're making.
Right.
Now,
Yeah.
one thing that you can also do is in Rhino, I believe that you can sculpt in Rhino. Within Freestyle, you have to import an OBJ file. So if you start creating that mesh in Rhino, which when I bring in Creo,
Right.
you can import it in as well.
And the nice thing about Freestyle too, it's in the default, base license of Creo. It's not, you're not going out buying an expensive extension or anything else, it's already there.
Exactly. You can also have some kind of geometric control. You can align the base of the mesh to a data plane. You can align the edges to the sketch. You can update the size of the sketch so the mesh will expand with it. So there is a little bit of like geometric control. So you can kind of imagine maybe it to be exhaust on a bike or something where it sweeps around the bike and around certain parts. So there's use cases for it in that way.
If you have an older version of Creo, when it first came out, it was limited to one primitive, one freestyle feature in a model. Now you can have multiples. Any other questions?
Can this be integrated directly, like, into a model tree of a Creo model you're currently making?
Yeah, it'll show up as a freestyle
It
feature.
just shows up as a freestyle feature?
Right, but it doesn't, you don't see like Sketcher and some of those other things you would see for an extruder revolve with sweep.
Does it start with the primitive then, or it does? So
You just have to
while you
choose
have your
which
50 features in the model, you want to put this freestyle feature in.
Right.
Sorry to interrupt. Yeah, what was nice too is that it was a hard edge in the mesh. So say that there's certain parts that are curvature. If there's a hard edge there, when you complete that feature, you can actually add a radius on there. So if you have to actually define the size of the radius, you can do that on the mesh as well.
And like I say, when I use it, I like working from the 2D primitive versus the 3, so that I'm basically working one half of the model, and then there's a mirror function that's in Freestyle that you can, if you think back, if anybody here remembers CDRS, right, ISDX now, is that you used to work in one half and then you had a virtual mirror. Well, it's not really a virtual mirror anymore, it's an actual mirror within the Freestyle function. Great, thank you.
yep.
Okay, we've got a break here for about the next half hour for going out and visit with the vendors. Please do so. And then about 3:30 we'll start up again. Set the mic prior.
I have a question for you. Didn't they use something, is this only for version 9, Creo 9? No. Because I remember it was...
started with Creo 5.
Okay, because I remember at your place, you were making your faucets with your finger and pulling it down. I think it might have been your son designing it.
Yeah, he was.
And that's why I didn't know. This is available in 6 now.
It's available in 6. It's already. If you just do new part, you'll see it in the upper right.
Testing.
It's already in there. All right, everybody ready? Got a thumbs up over here from Mr. Bailey, so we're all right. Enginsoft's going to be talking, and I'll let you explain what that is, because I'm not, I mean, I see multi-body dynamics, that part I understand. It's all yours.
Yeah, so my name is James Chris. I'm from Enginsoft USA. I feel like we did a little bit of a bait and switch on accident with putting MBD in the short title we've given. In this world, that is model-based definition. For us, in the CAE world, that is more multi-body dynamics. So I'll be kind of going over what multi-body dynamics is. And I'll explain the extremely long title that we came up with. But this is the agenda for today, so I'm going to go over who Enginsoft is, give kind of a primer on what multi-body dynamics is for those who aren't as much in the simulation space. And then I think probably the biggest takeaway for today is going to be when to use a dedicated MBD tool versus an embedded tool like Creo-RecurDyn. And then this is the sales pitch at the very end is an interface that we have between Creo and a dedicated multi-body tool. All right, so going into who is Enginsoft. Enginsoft USA is part of a multinational corporation. It was founded in the 80s in Italy, and we've since expanded into basically all of the companies, or all the countries in Europe, and then in the USA as well, over the past couple of years. So we're a simulation company through and through. We have several hundred experts. I think it's over 300 engineers at this point, with expertise in really every discipline of engineering and simulation. And we both sell customized solutions, so on the software side, as well as services, doing consulting, project-based work, that sort of thing. So this is sort of a duplicate of the last slide. I'll just jump over it. And then this is the fancy animation the marketing came up with. It kind of goes over the different disciplines we have expertise in. Obviously today we're going to be talking about multi-body and a little bit FEA should be on there somewhere. I guess mechanics. All right, jumping in. I guess before I do an explanation, who here is familiar with multi-body dynamics as a simulation concept? All right, good. So I'll start from the very beginning. I guess nobody's going to be bored. Multi-body dynamics is really a system-level analysis, and that's comprised of kinematics and contacts and multi-physics integrations. So kinematics is kind of a simple one. So going through each of these in one at a time. Kinematics is what you did in Dynamics 1, right? This is really simple stuff that gets very complicated when you have thousands of bodies to keep track of. So to compare and contrast with FEA, which is a little bit more well-known, multi-body is really dealing with rigid bodies. So unlike FEA, where you're discretizing a component and it can flex and move in complicated ways, with rigid bodies, we're really just dealing with a coordinate system, and it has some mass and moment of inertia properties, and then it's connected to other components. So in the software, you'll usually see some visualization of the geometry, but the solver doesn't actually care about it. That's why I say it can be reduced to a local coordinate system. And then we have joints connecting different components. So a really simple example. Can you see my? Yes, you can. So this is probably the simplest example of joints and rigid bodies. We have just a 4-bar linkage. So we have a revolute joint, which is limited degrees of freedom, right? So we have one rotational degree of freedom, that's a revolute joint. We have a universal joint, so we have 2 degrees of rotational freedom there, kind of offset from each other. Then we have a spherical constraint here, so that is basically all of the rotational degrees of freedom are open, but the translational degrees of freedom are locked. And then similarly, we have another rev joint at the bottom here. So by combining these really simple things, we can build up very, very complicated models. But the math is actually pretty simple. And basically any embedded solver should be able to do kinematics relatively well. Where it gets kind of complicated is in contact. So I want to do a brief primer of how contact is handled by multi-body solvers. You can see the result of contact up here. So we have two bodies, one is moving the other, so there's probably some torque applied out of frame here, and then that's causing movement throughout the system. The way this actually happens is we have sort of a help documentation view of what the solver is seeing as the software is moving along. I'll start with the search algorithm. So you can see this bounding box here, and typically there'll be some bounding box surrounding each component and looking at the actual geometry so that it can figure out when two components are close enough that they should be evaluated for contact. And then when they are that close, it's going to, depending on the way the contact is implemented, there'll be some discretization of the surfaces. So this is where the actual geometry itself matters. And we can see that there's a very simple tessellation for a simple geometry. That's all you actually need. And then we have this sphere. So for the sphere itself, we can actually represent that as a single point and a radius. So those are the kinds of simplifications you can make for evaluating contact. And when the software does this search algorithm, it sees, okay, we've got nodes from one body overlapping nodes from another body. We basically create a virtual spring that forces the two bodies apart from each other. So it sounds really simple, but as you play with different solvers, you'll see that some implement this very well and some don't. So that's kind of what separates your really simple, maybe it has contact, but you probably shouldn't use it, versus more enterprise expert level tools. And I'll go through more detailed slides on this, but I want to cover when to use a dedicated solver. So when you have contact-driven problems versus just kinematic problems, or when you have flexible components. So that's kind of a coupling between FEA and multi-body dynamics. Or if you have other multi-physics problems that you need to deal with, and lastly, automation. So starting off with contact, you can, as an experiment, you can try building this same model in Creo mechanism, and it will not be as stable, I can say that. So really, when you're dealing with complicated contacts, you have discontinuities. The solver is seeing, at one time step, there's no contact, there's no repulsive forces generated, and at the next time step, there is some non-zero amount of contact. And dealing with non-smooth functions can be challenging depending on the solver. Another thing that you'll notice differentiates kind of simplified multi-body tools and really advanced ones is the number of contacts that they offer. So you'll generally have some general contacts that are applicable in most scenarios, but as you want to build out more complicated models, it helps to have a lot of ability to fine-tune these things. So what we're seeing here is just a subset of the contacts available on RecurDyn, which is the multi-body tool that we carry. And by using these versus a different, a more general contact, your simulation speed increases. So the other difference between simplified, like Creo mechanism doesn't really support true flexible components, whereas any of your advanced solvers are going to have at least one, maybe two different ways of approaching that. I won't go into a ton of different detail on the difference between these or what fragmentation is, but basically this is a simplified way to deal with flexible components, and then this is a more general solution to that. So we can see this is almost like having embedded FEA in a transient solver. So I always like to describe it as almost a middle point between like an LS Dyna and your more traditional FEA tools. And then we have self-contact here. That's something, again, you'll see in some solvers and you won't see in others. This was a really good example of the RecurDyn solver, actually. So just to go off on, I guess, a brief tangent, this was some of my colleagues did this as a benchmark. So the customer, I don't think I can name who they are, but they kept having issues with premature failure of these CV boot joints, or CV joint boots. And basically, all of my colleagues knew at the time was that they had problems. So they got the geometry, built out the simulation model. This is a fully nonlinear, flexible component. I don't have a video on this, but And then they kept finding this weird buckling behavior on the boot. And they didn't actually have the results ahead of time. So they kind of went back to the customer and said, hey, we keep having this weird issue happen. We're not sure why, we're not sure what's going on. And the customer said, oh, that's exactly what happens in the physical model. That's actually the problem we can do about. So that was a very validating experience for them. All right, and lastly, I'll talk about multi-physics. So you can sort of use multi-body tools as a good central point for multi-physics or digital twin, depending on the buzzword that your organization uses. As they're a system-level analysis, they're a good point to plug on or bolt on other solvers. A very common one is control systems. So simulating a robotic arm, for example, is very common. Coupling with other fluid solvers is another very common one. This is coupling with a free surface CFD solver that we also carry. And then you can see the sloshing behavior, how that's going to affect your vehicle handling. So these are things that you really can't do in simplified or embedded solvers. And then FMI is a general interface for doing multi-physics simulation work. And lastly, automation. So there's kind of two different ways that this can be handled. The first is sort of pre-computed or pre-generated solutions. So we call them toolkits. In RecurDyn, every enterprise level MVD solver is going to have different add-ons you can purchase to automate certain building of certain systems. So that's kind of what you're seeing here. If you had to go through and manually create geometry and create paths to connect this chain system or this build system, it would be very, very tedious. And some tools help you a lot with that, some tools don't. RecurDyn happens to have best-in-class tools for this, so you basically just say, I want this thing, and this thing included in the assembly, and it'll figure out the paths and stuff for you. Another thing that you'll find in dedicated tools is scripting environments. So a lot of times these are included in the base package. They're not an add-on. So for example, with Creo, you can pay for the toolkits or the development kit, whereas with a lot of the advanced S8 or CAE's tools, those will be included for free. Okay, so I've kind of talked about all of the cases where you want to use a dedicated MVD tool, right? But what makes that difficult? And it's one word, geometry. So this is probably the most common complaint that I get from customers is, dealing with geometry is kind of a pain, right? They have everything built in, we'll use Creo as an example. They have everything in Creo, right? And moving that over to the simulation tool, regardless of whether it's RecurDyn or any other MVD tool, is kind of a pain. And anytime the Creo model changes, then you have to go through this whole export process and import process, and it's sort of a nightmare. Another thing is metadata. I'll say metadata is anything kind of just about the model is lost, so you often have to redo a lot of work. Revision control is difficult because it's not using native CAD usually. Under the hood, it's using some other kernel. So it's not semantically linked to your windshield, for example. You end up duplicating a lot of work. So obviously I'm here to talk about something that we built to address all of these concerns, and that's the Creo-RecurDyn interface extension, or we call it CRIX. So I have a couple of slides, and then I'll go through and kind of narrate an example video of it. So we tried to simplify the process for exporting data from Creo. We wanted to give you a portable file. So a lot of times the simulation department is different than the design department, and it's a little bit of back and forth to get data from the designers and send it over to the simulation people. So we wanted a portable file that makes that sharing easy. You can automatically launch RecurDyn from Creo, so start from Creo and then end up in RecurDyn in kind of a guided manner. You can merge subassemblies into bodies. I'll explain why this is extremely important as we're going through the video. And then, so I'm calling these mechanism style constraints. So in Creo, how many people here are using like the pin constraints versus more of your geometric constraints when building assemblies? Okay, so would it be great if you could reuse those in a simulation model? So we absolutely wanted to support that, and we cover, I think, all but a handful of the mechanism style constraints in Creo.
When you're talking about the mechanism style constraints, if you have flexible components using the Creo flexible, does it retain any of that?
It's not using that. It's using, so, and the reason I say mechanism style is you don't actually need mechanism for these. It's just when you're placing the components and defining degrees of freedom rather than fixed points in space. So it basically saves you a lot of the setup process. And if those are, if you make some geometry change and that propagates to moving where that pivot point is, for example, then you want that to automatically get pushed over instead of having to go and find that marker and move it. So it saves you a lot of time there. And then another thing is, especially on larger teams, finding out what has changed since you last exported your model. I see a chuckle. That can be an entire afternoon, right? You ask somebody, hey, what did you change? I changed this, this, and this. They actually changed another thing and forgot about it, and you now have to redo all of your simulation work. So we keep track of all of that for you, and we handle that. So, and then the workflow that we're going to go over, basically, so you export from Creo, import into RecurDyn, and then that starts the process. And anytime the model updates, we simplify everything moving forward. So this is playing good. So this is actually a super fun demo model that I found on PTC's internal site. So this is a fully designed Lego model, and there's a ton of detail. I think there's 700 parts in here. So we can see we went to the Applications tab, we put a single button, so we try to make it very, very simple. We put a single button into the Applications tab, click on that, it does a big scan of the assembly. This is probably going to outrun me, so I'll pause it really quickly. So then these are the only options you have to deal with on the Creo export side. By default, it's just going to export what is visible in the model. That's one thing that I have an issue with Creo. I don't use it a ton. So it's always kind of a nightmare going through and saying, okay, I want to export this subset of the model. I'm sure there's faster ways to do it, but I don't do it enough to learn them. So we wanted to say, if it's visible, it'll get exported. If it's not visible, it won't. You can obviously switch and do the more traditional selection or deselection. But the nice thing about if you do it this way, if you have you can define views, and I'm blanking on the name of it. You can set up a view of these are all of the simulation components. That's a Creo thing.
Like a simplified representation.
Thank you.
Okay.
Yep. Yeah. So if you have a simplified rep for RecurDyn stuff, or just one that already exists for simulation, you can reuse that. So again, we want to make sure that you can reuse as much data as possible. Choose whether export joints or not, and then by default it'll automatically launch RecurDyn. This is what the RecurDyn interface looks like. We'll go through detail on this. So this is what happens when you import the model. It gives you a director, or a structure, a tree structure of everything that was in the Creo model that has been exported. And then it's going to map those into, we call them subsystems. They're effectively the same thing as a subassembly. So by default, we're keeping the assembly structure, but you have the option of reducing things down. So a lot of times you might have multiple bodies or multiple parts that are actually bolted together. For simulation purposes, you want them, you might want those combined into one component, right? So you have fewer constraints applied to it. So me play, I don't know, I think I do at some point here. Basically, you right click, say merge, and then that's all you have to do. And then moving forward, any update to a subcomponent inside that assembly will then be applied. Yep, so we have convert to body. And then it's defined as one component. So it really simplifies things, and then you don't have to go digging through any time you have to update the model. Okay, so I've converted a couple of things. I'll skip ahead. This model doesn't have any joints in it, so that's not shown here. We do have other presentations. If you're looking for them, or we can talk after, I can show you those where we do kind of look at the joints themselves. So this, it's going to go through and import everything, kind of making sure everything's in the right spot, organizing everything, storing that metadata. Jump through. So we can see there's a lot of components here. Okay, and now I'm just going to go in and look at what happens when you merge a subassembly. Give it a second. Sorry, I have no idea what's going on with this video. It keeps jumping around. Okay, so now I'm going to go into this subassembly, and if I keep going one level down, it's going to go into, I think the tiny car that's in the trailer, and we'll see that this is considered a single body, so we can constrain it very simply. But let's pause it here. Okay, so now I'm in one body, which so we can see that there's the little car in the trailer, and each of the parts is still available as a solid. So if I go into the body, I can see everything that's in there. I have all of that geometry information. If I need to define contacts with one of those surfaces, I can. But I still I have the simplicity of seeing it as one component in the model tree. And then the last thing I'll show is the update process. Let's see. Okay, so in the kind of contrived example, we're saying that this Lego piece was wrong. So in reality, I'd probably have to swap out a bunch of geometry. But I'm just going to do a Boolean cut to shorten it. And then I jump ahead to where okay. So then to sort of simplify the export process, I change so that only this component, because I only actually updated one thing. We'll pretend that I updated a whole bunch of stuff. It works exactly the same. So I'm going to make only this assembly visible. So I'm hiding everything else so I can run through the export a little bit quicker. And then the export process on the Creo side is exactly the same every time. So from the designer's perspective, if they're the ones exporting and then sending it to simulation, they just have to do the exact same stuff every single time. And then send the Crix file to single file, send that to the simulation people. Right, so we've exported it, and then it's going to open up, ask me if I want to update it. So we jump past, it goes in, finds the object, reassigns contact as necessary, so anything you've already added to the model after doing the import gets preserved. There's some kind of tricky things we have to do to make sure that happens. Then we swap out the geometry and return you back to the main view, and you're ready to simulate. And the same thing applies if you updated one thing or 20 things, or if you don't know how many things you updated. Because somebody else is making the changes, it'll go through, find everything based on timestamps, and make those updates. And then it gives you some log output at the end, so you can kind of sanity check what happened. All right. I appreciate everybody's time. I hope that was informative. And if there's any questions, I'm happy to answer. And we also have a booth outside, so.
Any particular, I mean, I assume any version of Creo would work with it, or is it version specific?
6, 7, and 8. We haven't added Creo 9 yet because no Fortune 50 companies are using Creo 9, but that'll be an easy add.
Any questions?
I'll be over there during the break. If anybody has simulation questions about MBD or any other type of simulation, I'm happy to talk to you.
All right, Joe's going to hand out tickets for prize eligibility, and then we're going to have a little more time available with the vendors, so before they.
So why don't we do this to make it simple? We'll go through this door, I'll hand you a ticket, you can go out to see the vendors, I'll set up the gift cards and everything, we'll have a drawing right after. And this way I can make sure you all get a gift card.